So this is pretty much just a review of what we've covered already in this unit. So that's good because we are taking the test next time. Write the equation in slope-intercept form for each line based on the information given. So all of our equations should be written in slope-intercept form anyway. So we got y equals mx plus a b. And up in here, they said the sloppage, which is m, is negative 1/2. So I'll replace m with negative 1/2. And then it said the y-intercept is -5. It should have said it was 0, -5. But that will do. We just need to replace b with the -5 then. And there's our equation. Number 2, the line has a slope of 4 and goes through the point 6, -1. So on this one, we're going to have to use point slope form. So that is y equals m times x minus the x value given. And then we'll add the y value that was given. So up in here, we can see that the sloppage is 4. So again, we're going to replace the sloppage with 4. And then we'll replace the x value from the point with the x1 in the equation. And we'll also be replacing the y. So the x value they gave us was 6. The y value was -1. Now we'll just simplify this into slope-intercept form. First by distributing the 4. So that would give us 4x minus 24. And of course we still got the -1, so y equals this stuff. So y ends up equaling 4x. And then -24 minus 1 is -25. That is the equation for number 2. Now we got a line that contains these 2 points, so the first thing we're going to want to do on these is to figure out what the sloppage is. So from 7 to -3, you would go down 10. So that's our numerator in the sloppage, down 10. And then from 2 to 3, that would be to the right 5. So -10 divided by 5 is a -2. So again, we'll use point slope form. Y equals the sloppage, -2 times x minus, this one we'll use 3, -3, so -3, and then a -3 up in here. So x minus the 3, and then minus that 3. So again, we'll simplify this to get slope-intercept form. -2x plus 6 minus 3 equals y. And then fully simplified, we got -2x equals 6 minus 3, which would be +3. So on the table, we just need to choose 2 points to figure out the good old sloppage. Doesn't matter which 2 points we choose. I'll use these 2. Doesn't matter. So from -2 to 2, this was up 4. So in our sloppage, we got up 4. And then from 1 to 2 is up 1, so it's over 1. So we'll just say that it's 4. So in the equation, we got y equals 4 times the x. And this one actually gave us the y-intercept right here. 0, -6. So the y-intercept is 0, -6. There we go. All right, what about this? So which 2 points do you guys want to use to find good old sloppage? All right, let's use these 2. So from 2 to 1, you would have went down 1. And from 2 to 4, you would have went up 2. So it looks like the sloppage is -1/2. And to change this into slope-intercept form, we will have to use point slope form because it did not give us the y-intercept. So y equals -1/2 times x minus whatever x value we get. And we'll use 14, -4 on this. Again, it wouldn't matter which point you use. You should get the same equation either way. So distributing the -1/2, we got a -1/2 x. And -1/2 times -14 is a +7. Of course, we still have that -4. So y equals this stuff, and y ends up equaling sloppage negative 1/2 times the x, and we got 7 minus 4, which is a positive 3. So this is our final slope-intercept form equation. Number 6, we got to find the equation for this graph. So we just need 2 points on the graph. Well, this is a good point to start with, down radical. 0, negative 9. Why is this a good point to start with? Because it is the y-intercept. We can look at the x-intercept as well. We'll just do 9, 0. So if you want to, you could use rainbow method on these. 0, negative 9, and then 9, 0. So to find good old sloppage, we went up 9, and then over here we went to the right 9. So 9 over 9 equals 1. That's our sloppage. So far the equation is y equals 1x, and then we already did find the y-intercept radical, which was 0, negative 9. There's the equation. So this line, we can't identify specifically where that y-intercept is. So we'll have to figure that out using point-slope form. But let's look at some other points that we can use on these, just to find the sloppage. There's a point, and there's one, there's another one. There's lots of points we could use up in count. But we only need to use 2 of them, really. So I'm going to use these top 2 radical. So my slope triangle, I went up 3, and then to the right 4. So my sloppage is 3/4. Now again, we'll use point-slope form to solve this thing. And we can see the sloppage right there is 3/4. We just got to figure out which point we want to use. We'll try this one radical. 2, 4, yep. So it's 2 and then a positive 4 radical. And again, all we got to do is simplify this thing to get it to slope-intercept form. So y equals 3/4 x minus 3/2. That's 3/4 times 2. And then plus the 4. Now I got negative 3/2 plus 4. To make this a common denominator, I'm going to change that 4 into 8/2. Which should make the fraction addition there a little bit easier. So y equals 3/4, our sloppage, times the x. And then negative 3/2 plus 8/2, I get 5/2, a positive 5/2. And there's the equation for this thing. And I mean, we could have guessed that y-intercept is 2.5, but without the work, we can't know for sure. So it is crucial to show this using either point-slope form or slope-intercept form. So again, we're trying to find the equation of this thing, and yes, we can identify the y-intercept at 0, 1. So in the equation, we'll have y equals something, x, but then plus the 1. So we got to figure out sloppage on this thing. We'll use these 2 points, 0, 1. I'm going to use 0, 7. No, that's not 0, 7. That's 7, 1. Sorry, let me take that back. 7 of 1. So to find sloppage from 1 to 1, that's an addition of 0. And from 0, 7, that went up 7. So our sloppage is 0 over 7. Which really just comes out as 0. So I got y equals 0x plus 1. Really, we could just write y equals 1. I'm okay with either one. So on this problem, we notice that the line will never cross the x-axis. I'm sorry, the y-axis. So it has no y-intercept. So this one, the form of the equation will be very different. Of course, if we identify these points, we can see that the value of x is 1 each time. So this is 110, and maybe this one is 15. This one is 10. Down here, this is 1, negative 8. So the x value is never changing, even though the y value is, which means that the equation of the line is just x equals 1. No matter what y is, x will always be 1. Now this equation is not anywhere near slope-intercept form, but we can manipulate it so that it is. So the first thing we'll want to do is distribute that 2. Alright, so distribution of this 2 gives us a 2y plus a 2. And then, well, we got this x over here, which, let's move it to the other side so it will be more like slope-intercept form. So I got a 2y plus 2 equals, well, those x's canceled out. X minus x is 0, and we're left with negative 14. So to solve this, we'll subtract 2 from both sides. And now we got a 2y equals negative 16. And to solve this thing, all we're going to do is divide by 2 on both sides. And we get y equals negative 8. So this is the equation that we're graphing. So we saw on the last couple examples there, this is just y equals negative 8. So where does y equal negative 8? I got a point right there. It's just going to be all along this line. Radical. That is where x is, I'm sorry, y is negative 8. Radical. This one doesn't take any manipulation on our part, so we're just going to graph the equation of the line where x is 1. Actually, we did that already, right? So where is x 1? Well, at this point. And x will be 1 all along this line right here. There it is. Again, the same idea. X is 1 everywhere there, no matter what the y value is. Okay. So we could find an ordered pair, and like this one. Well, that's 1, 8. Again, the x value is 1. It's just always going to be 1. All right, let's graph this equation. Y equals negative 1/4 x. So what's the y-intercept on this equation? It's 0, right? Would have to add 0 to that. So the y-intercept is at 0, 0, which is radical. And then we got the sloppage, which is negative 1/4. So I'm going to make the 1 negative. Meaning I'll go down 1 and then to the right 4. Down 1 to the right 4. And we can continue this pattern in the other direction as well. And that gives us these points. So, draw the line through these. That's it. That turned out really good. For 13, do we have the y-intercept? Yes, we do. What is it?
It's number 10.
This one's y equals x minus 8. Well, yeah, we got the y-intercept there at 0, negative 8. So 0, negative 8 is this point right here. And then the sloppage, there's a phantom 1 in front of that x. I'm just going to make it 1 over 1. So if I continue my stair step right here, we get points all along this line. There we go. I didn't show the stair steps for all of them, but you can.
Oh, but it's because the slopes went. Okay.
Yep. Up 1 to the right 1.
Yeah.
So yeah, there's our line. On 14, this one's in standard form. So what we'll do is change this into slope-intercept form. So what do we got to do? Well, we'll subtract 7x from both sides. So this 0 pairs away, and we got y equals 9 minus 7x. Well, we got two terms, 9 and 7x. Let's just switch those. Make it a negative 7x plus 9 equals y. Well, this is great because it gives us the sloppage and y-intercept. And now we can graph the y-intercept at 0, 9. Which is right here. And then using the sloppage, which is -7. I'm going to make it -7/1, which tells me I'll go down 7 and then to the right 1. So down 7 to the right 1, and I'll continue this pattern. It's a pretty steep line. Let's see if I can do this.
Do
Okay.
you like those stairs, Mr. Sal?
I don't like these stairs, unless I was going down them, maybe, you know. But I may need a parachute.
You may need a.
Well, let's get started on 15. Again, this equation is in standard form, -3x plus 5 of y equals 30. Let's go ahead and change this into slope-intercept form. So right here, we'll get rid of that 3x. Let's add 3x to both sides. And now we got 5 of y equals 30 plus 3x. But again, we can switch these around so that it looks more like slope-intercept form. So now I got 3x, and then that was a positive 30.
But we still have 5.
Yep, so let's get rid of that 5 by dividing everywhere by 5. So that gives us a y equals, now this will be 3/5 x, plus 30 divided by 5 is 6. And that's great because it gave us the y-intercept at 0, 6. So we don't have to be searching for other points, for a point to start with on this. We can start with 0, 6. All right, so starting with 0, 6, we got this point, and then our sloppage was 3/5. So I would go up 3 and then to the right 5. But that's the only point I can fit to the right. So I'll use this pattern going backwards. And right 5, left 5, and down 3. And we can fit even more on there. Left 5, down 3. So there's all our points. That looks okay. And there's our line. Now, yeah, if you guys wanted to erase this garbage so that that red line isn't showing, that's up to you. Because it's not really, it just helps us to figure out where the line is not, it's not actually part of the line there. That looks pretty good. So, the slope of the line is -1/2 and the y-intercept is -5. So we can write this out in slope-intercept form. Y equals mx plus b. M is the sloppage, and the b is the y-intercept. And up here they told us that the sloppage of the line is -1/2. So I'm going to replace my sloppage with -1/2. And then I will replace my y-intercept with the value they gave us, which in this case was -5. So I'll put in -5. There's the equation. Number 2, the slope, the line has a slope of 4 and goes through the point 6, -1. So in this one we will need to use the slope-intercept form to find the y-intercept. So we got this y-intercept, which is y equals the sloppage, which is 4. And then we'll multiply this by x, and then add the b. And we'll solve for the b by replacing the y and the x with the two values they gave us. The x value is a 6, and the y value is a -1. So 4 times 6 is 10. 10 equals -1 plus b, so something plus 10 should equal -1. We'll subtract 10 from both sides.
Isn't it 4 times 6, 24?
Oh yeah, that's what I meant, thank you, that's close. That should be 24. So we'll subtract 24 instead. That sounds much better. So instead of 10, 24. And -1 minus 24 is -25. Is the b value. All we need to do is write the equation. Y equals m, our sloppage of 4 times the x, plus the y-intercept, so minus the 25. There it is. Alright, well, what about the line that contains these 2 points? First thing we're going to need to do on these is to find the slope. So from 7 to negative 3, that's going to go down 10. And from negative 2 to 3 would be to the right 5. So we got negative 10 over 5, which simplifies. And you can check that on a calculator to negative 2. So we have our sloppage. So we got y equals the sloppage, negative 2, times the x, and then plus b. So we just got to choose which point we want to use. I'm going to use negative 2, 7. So I will replace x with negative 2. And I will replace the y with the y value, which is 7. And then solving negative 2 times negative 2 is 4. 4 plus b equals 7. So solving, we subtract 4 from both sides. And we get b equals 3. So we can write the equation now. Y equals m, which is negative 2 times the x. And the b value we had was a positive 3. We'll write the equation for the table here. So the first thing we need to do is find the sloppage. I'm going to use these 2 points here at the end. So from 2 to 6 we would have to go up 4, and from 2 to 3 would have to go to the right 1. So our sloppage is up 4 to the right 1, which just we can write as 4. And then, fortunately for us, they gave us the y-intercept 0, negative 6 radical. So we can write that equation right now. Y equals 4x, and then 0, negative 6. Line contains the point in this table. I don't know. Let's use these 2 middle ones. To find the slope, so from 1 to negative 1, we'd have to go down 2. So right now our slope is down 2. And from 4 to 8, we'd have to go to the right 4. So negative 2 over 4 simplifies to negative 1/2. And again, we'll use slope-intercept form to solve this. Y equals negative 1/2 times x. And no, they did not give us the y-intercept, so plus b. Now we can replace the y value and x value with whichever point we choose.
Can we do 2, 2?
Yeah, let's use 2, 2. So the x is 2, and the y is 2. So solving this, negative 1/2 times 2 would be negative 1. And then we still got this 2. 2 equals negative 1 plus a b. And then to solve for b, we would add 1 to both sides to get rid of that 1. So we got b equals 3. Now we can write the equation. Y equals the sloppage, negative 1/2 times the x. And then the b value was 0, 3. So we need to find the equation of this line. And we can see several points radical, but this one will be pretty important. Not necessarily to use, but just to notice. That's 0, negative 9, which is our y-intercept. That's very nice. And we just need to use any other point on the count. It doesn't matter which point. We can use this one. 5, negative 4. So to find the sloppage, I mean, we could rewrite these out of count. But we could also use a slope triangle, like this one. So it appears that I went up 5, and then I went to the right 5. So my sloppage was up 5 to the right 5, which simplifies to 1. 5 over 5 is 1. Now we got to find the y-intercept, which we found already. So we got y equals mx, and the sloppage is 1m. And then the y-intercept is 0, negative 9. There it is. On this one, we can kind of estimate that y-intercept, but we shouldn't. We should just be able to solve for it. So let's do that. And let's identify some points that we can use to find the sloppage. So it looks like we got a point radical. There's another one. another, and another. It doesn't matter which of these 2 points we use. We just got to choose 2 of them. And I will choose, I don't know, the 2 end parts. Like these. So it looks like I went up 15. So up 15. And then I went to the right 20. Yep. So this should simplify to 3/4 for our sloppage. Now we use slope-intercept form to solve these. Y equals 3/4 times the x value plus the y-intercept. Now we had several points right here, and we only need to choose one of them to use. Let's choose this one, I guess. Doesn't matter. This is -6 and -2. So I'll replace my x with -6. And my y value with -2. And solving these, 3/4 times -6 would be -9.5. That's plus b. This equals -2. So to solve this now, I would need to add 9/2 to both sides. And I got my b equals -2 plus 9/2. Like these. But I can change my -2 to have a common denominator. That's -4/2. So that comes out to be a positive 5/2. So our equation, y equals the sloppage, 3/4, times the x value, plus the y-intercept, 5/2, which is about what we would expect right there. That point is about at 2.5, so that should work out. And there's our first page. All right, we'll write the equation of this line. So we should have it in slope-intercept form. Y equals mx plus a b. And to find the sloppage, it doesn't matter which 2 points we choose. These 2 will work. I can see that my rise right here is 0. And for me, I would go to the right 6. 0 divided by 6 is 0, so my sloppage is 0. Now I need to identify the y-intercept, which is right about here. That's at the point 0, 1. So I can replace my y-intercept with 0, 1. Now 0 times anything is going to be 0, so that really just cancels out, and we get y equals 1. On this one, first off, we can look at this and notice that it has no y-intercept. So what we need to do here is identify a few points. Doesn't matter which points we identify, but if we look at this, since it has no y-intercept, the slope-intercept form won't work. And right here I got 1, -8. This one is 1, -3. This one is 1, 3. And then 1, 8. Or this point even, doesn't matter, 1, 5. So we can see in all these points that the x value is 1. No matter what the y value is. That's okay. They don't have to be opposites. So what this means is that x equals 1 no matter what. So that will be our equation. All right, now it wants us to graph these equations. But this one's in kind of a weird form. It's not standard form. It's not slope-intercept form. So we have to simplify this. First off, we'll need to distribute the 2 into the parentheses. So 2 times a y gives us 2 y's. 2 times 1 is a positive 2. All right. Now I need to move my x's to the other side of the equation away from the y. So I'm going to subtract x from both sides. And this zeroes out, but as it turns out, this one zeroes out as well. We're just left with 2y plus 2 equals negative 14. So to solve for y right here, we're going to subtract 2 from both sides. And I got 2y equals negative 16. Finally, to solve, we'll just divide both sides by 2 right here. And we get y equals negative 8. So this is the equation, and similar to the problem that we just barely did, we got y equals a value. So we just need to solve on the graph where y equals 8. Negative 8 for this one. So where is y negative 8? I can see it's radical. So it's just going to be this horizontal line like a these. The equation of the line is x equals 1. Well, where does x equal 1? Right there. Right there. All along this line right here. So this one's a vertical line. Right there. So this one equation is actually already in slope-intercept form. It just didn't show the y-intercept because it's the additive identity plus 0. So this puts our y-intercept at 0, 0, which is radical. Now my sloppage is negative 1/4, so I'm just going to make the 1 negative and the 4 positive. So that means from here I would go down 1 and then to the right 4, giving me my next point. And repeating the pattern to the right and then to the left. Again, making my staircase. All I need to do now is draw my line. That'll do. And that's the line that we want. That represents this equation. The equation of the line is y equals x minus 8. And we can put a phantom 1 radical in front of the x to show the sloppage. Now we got the y-intercept at 0, negative 8. So we can graph that point. That's where we need to start. Then I'm just going to use the sloppage 1/1 to find the other points. So I go up 1 to the right 1. And then up 1 to the right 1. And this pattern repeats. Alright, so there's all the rest of our points. All we need to do now is connect them. That'll do. Yes. Alright, now it gave us an equation in standard form, which is no good. What we really want is slope-intercept form, so that is what we will do. So we don't want the 7x with the y, we want it on the other side of the equation. So I'm going to subtract 7x from both sides. And that gives us y equals 9 minus 7x, which isn't really slope-intercept form in its formal form. So what I'm going to do is, again, I'm going to switch those two terms to make that a negative 7x and then a positive 9 like these. And that gives us the y-intercept at 0, 9, and also the sloppage at negative 7, but I'm going to make it negative 7/1. Alright, so starting with the y-intercept, 0, 9er, which is radical. And then my sloppage was down 7 to the right 1. There's my next point. Down 7 to the right 1. And that's all the points we can fit on this graph. I missed it. That's okay. So there's our line. Once again, we have an equation in standard form, but what we really want is slope-intercept form. So what we will do is we will change this into slope-intercept form. And to do that, we're going to add 3x to both sides so that the y is by itself. Oh, that's a 3x.
You erased it.
So now we got 5 of y equals 30 plus 3x. But again, I can move those around and make that a 3x plus 30 equals the 5 of y. But we got that 5 there. And we have all the y's on their own side, but we only want one y. So we'll divide everything by 5 to get rid of it. So these 5's cancel out. we got y equals 3/5 x plus 30 divided by 5 is 6. So we have our y-intercept at 0, 6,
On both sides.
and then we got our sloppage at 3/5. All right, so now we'll graph our y-intercept at 0, 6, and our sloppage is up 3 to the right 5, and the next point won't fit on our graph, but we can go the other way as well. And it looks like we fit these 4 points. Now we just need to connect them. That'll do.